Alright, so here we go for another question. We've got a ball which is thrown at a certain time with initial velocity 15 meters per second and 75 degrees to the horizontal. So A, calculate the magnitude of the vertical and horizontal components of its initial velocity. So I'm going to make a sketch here, not necessarily up to scale. Okay, so let's say that this is my initial velocity. I'll call it U 15 meters per second. Good. So we can decompose this into two components. So let's decompose this into a horizontal velocity and a vertical velocity. Now we know that this angle here is given. It's 75 degrees. Now if you look at your booklet, you do have those equations straight away. You can see that ux, I'm going to call ux and uy. Okay, so we can find that ux is simply u cosine of the angle that you have there, theta, and ui will be u sine of theta. Now those will work when your angle is with the horizontal. If your angle is with the vertical line, then those will flip. Sine will be your horizontal and cosine will be your vertical. But if it's like this, as we usually do, counting from the horizontal line, you will get cosine and sine. And I've shown in class, you can watch the previous videos, or if you still have doubts, ask me, but this is trigonometry, right? This is, you're basically doing SOHCAHTOA to find those relations with a right triangle. For this particular problem, u is 15, and our angle is 75 degrees, right? So let's use our calculator for this. Now the first thing that you have to worry when you're working with angles and using a calculator is to check if your angles are set up correctly. So if you press Shift menu and you scroll down all the way to angle, in this case it's configured for radians, but I want to use degrees just because my problem is measuring angles in degrees. So instead of converting 75 degrees to radians, and perhaps you might even make some approximation error, or you might do some wrong algebra, I don't care. The thing is, if your calculator has a setup for degrees, why would you bother converting those things? So just set it for degrees. So if we take the first case here, 15 times cosine of 75, and we have our value there. So this is 3.88. And I'll keep up to 3 significant figures, even though it's a bit too much, isn't it? Let's do 3.9 meters per second. Now what about the second one? Well, we have to do 15 times sine of 75. And then it's 14.5. Now here, notice that if I take too few significant figures, if I round this up, I would get back to 15. So yeah, do worry about your roundings. Okay? So letter A is done. Letter B, calculate the magnitude of the vertical component of your velocity at 0.5. So the vertical motion is going to be, the ball is going to be thrown up, and it's going to be pulled down by gravity, right? So it's being stopped. It's decelerating, since the acceleration is in the opposite direction of the velocity. So if we observe just the vertical motion, it's a one-dimensional motion, right? So we can just use the SU-vet equations that we know. Now, since we do have gravity, so we have an acceleration, what do we know here? Well, we know the initial velocity. We know our acceleration, which is gravity. We know the time, which is given, which is 0.5 seconds. So this one is actually fairly simple, because we can calculate the final velocity using the initial velocity. In this case, I can just do this for y. So the final velocity will be the initial velocity plus your acceleration multiplied by time. And in this case, it would also be your acceleration on y, because there's no acceleration on x. So your final velocity, or, well, your velocity at 0.5 seconds would be your initial velocity, which was 14.5 meters per second. Now, this acceleration is against this velocity, so it would be negative 9.8 times your time, 0.5. So if you work those numbers, you should get 9.6 meters per second. So letter B is done. Now letter C. Calculate the vertical component of the velocity of the ball at t equals 2 seconds. So let's see. If we apply the same equation, Vy equals Ui plus Ayt, my initial velocity is still 14.5 minus 9.8 times 2.0. So this is negative 5.1 meters per second. So since this velocity now is negative, it means that it's going on the opposite direction. So the ball is moving down. Letter C is done. Now letter D. What is the magnitude of the horizontal component of the velocity at 2 seconds? Now, horizontal, since this motion is a projectile motion, the horizontal movement, the horizontal motion is constant. The horizontal velocity will not change, right? Because there is no acceleration on the x-axis. There's only gravity, which is up or down, right? It's just interfering with the vertical movement. But on the horizontal movement, there's nothing to change the velocity. So Vx is the same as Ux. So the horizontal speed is constant, which would be 3.9 meters per second.